Today we're going to go over hyperbolas, and you are going to notice several similarities between hyperbolas and ellipses, so you're going to have to be careful to also notice the differences. I want you to be able to find the constant difference, so there's one difference between the ellipse and the hyperbola, and also determine if a hyperbola is horizontal or vertical. Also identify the center, A, B, C, foci, and the slopes of the asymptotes. If you pull the two foci of an ellipse so that they are outside of the ellipse, the result would be a hyperbola. Now these are vertical and horizontal hyperbolas that are centered at 0, 0. Now I've highlighted in yellow some things that are different between, or new. So with a hyperbola, instead of a major and minor axis, you're going to have a transverse axis, which is the axis that the vertices are on, and you're going to have a conjugate axis, which is the axis that the co-vertices are on. So you can kind of just remember that the conjugate axis starts with a C, and the co-vertex starts with a C. Another thing that I have highlighted here are the asymptotes. And we're just going to be concerned with the slopes. We're not writing the equations for them. So when we get down to the other table, it'll look a little bit different than what I'm expecting you to do. Okay, but you still have co-vertices, you still have vertices, you still have the two focus, so we still have foci. Now, I put a red arrow next to this because I want you to be really careful. Make sure that when you graph your hyperbola, these are called branches. They're not called parabolas. The branches have to go through the vertex, so it has to touch or go right through the vertex. Don't graph them up high or around the focus. And we'll talk about that graphing more tomorrow. Now, while the constant sum measures the length of the distance of the string that forms the ellipse when connected to two pins, the constant difference is the difference of the distances from a point on the hyperbola to each focus. So the constant difference is found by, so very similar again, the only difference between the ellipse and the hyperbola is now we're subtracting the distances from the foci to a point on the branch of the hyperbola. This is always going to be positive, so you're going to take the absolute value. I highlighted that. You might want to make a little note of that, or just know that the distance, we're always talking positive distance. All right, so we have an example here that we are going to find the constant difference for hyperbola with these two foci and a point on the ellipse. So I just quickly sketched. This is going to be oriented horizontally. If you just put these are both on the transverse axis. So the branches will go this way. And then we have a point that is 830. All right, so same thing here. I would strongly recommend just lining up your points. If you don't want to draw the diagram, that's fine. But notice that never put the two foci together. So I'm going to do the same thing here. I'm going to do a point in the first focus, the point in the second focus, and then I'm going to do the distance formula for each one. And once I have the distance formula, I'm just simplifying here. And this first part is going to end up being 34. The second part is going to end up being 30. And when I subtract them, it's 4. Now, had I done this in a different order, had I started with this one and subtracted that one, then it would be 30 minus 34, which would give me a negative 4. I would take the absolute value because we're talking distance, so it needs to be positive. Okay. Now take a quick look at this. These are standard form for an equation of a hyperbola. Now these are centered at HK. They're not centered at 0, 0, so we're subtracting our center from the x and the y. Okay, notice here that A is always first, or A squared I should say. So that's a difference between the ellipse and the hyperbola. Another thing that I want you to notice is that we have asymptotes. And again, we'll talk about the actual graphing, but for today I'm just going to have you pick them out from an equation. So if it's horizontal, so you need to first decide if it's a horizontal or a vertical ellipse, or sorry, horizontal or vertical hyperbola, and then you'll be able to tell if the slopes are positive and negative b over a or positive and negative a over b. So these are really easy to find. We're not writing the entire equation. Again, we are just writing the slopes. All right, so we're going to identify the center A, B, and C, and the slopes of the asymptotes. So same thing as an ellipse. When a hyperbola is in standard form, it's always set equal to 1. A, B, and C are all measured from the center, so sounds like just an ellipse. The denominators in the equation of a hyperbola represent a squared, b squared, a squared and b squared when dealing with hyperbolas. Now here comes a difference, a huge difference. A squared is always the first. Let's see, actually, I think I need a denominator in here, don't I? When dealing with hyperbolas, a squared is always first. Okay, and it is in the denominator. It's not always going to be the largest one, but it will always be the first one. C is found by using, and I highlighted the addition sign here because here's another difference between a hyperbola and an ellipse. C is found by using c squared equals a squared plus b squared when a and b are known. Now this is the same as an ellipse. A, not a squared, is the distance from the center, but this is to the vertex, so that's exactly the same. However, A could be bigger than B, A could be smaller than B, or A could equal B. All three of those things can happen, so that's a huge difference between a hyperbola and an ellipse. B, not B squared, is the distance from the center to the covertex, so that's the same. C is the distance from the center to the foci. Again, the same. But how we find C is different. Okay, so everything's measured from the center. All right, we're going to do a couple of examples here. Here is my first equation for my ellipse. Or sorry, I keep saying ellipse. Sorry, it's hyperbola. We want to figure out if the hyperbola is horizontal or vertical. Now, for an ellipse, we always looked for the biggest number. That's not the case for a hyperbola. For the hyperbola, you look at the first term. So if the first term is y, that means it's vertical. If the first term is x, that means it's horizontal. And you can see that over here on your table that's on the first page. Horizontal, x is going to be first. Vertical, y is going to be first. All right, now our center is at 0, 0. And just be careful, when these are flip-flopped, you have to make sure, like if this was y minus 3, then the coordinate for the center of this hyperbola would be 3. All right, so our center, we'll go on from there. A is going to be the first denominator. Again, it's not always the biggest, but it is always the first. So A is the square root of the first denominator, so that's going to be 5. B is the square root of the second denominator, so that's going to be 6. And we're going to find C by doing c squared equals a squared plus, not minus, b squared. So that's going to give us approximately 7.8. All right, now we're going to find the vertices. A is going to be here, and we're going vertical, so we know we have to go count 5 on the y-axis. So from my center, I'm going to add and subtract 5 from the y-coordinate. So that's 0 and 0, negative 5. And then the covertex, I'm going to add and subtract 6 from the x. So 6, 0, negative 6, 0. And then for the foci, I am going to, the foci are always on the same axis as the vertices. So we're going to add and subtract 7.8 to our y-coordinate. So that's going to go 0, 7.8, and 0, negative 7.8. All right, now the next example does not have the center at 0, 0. So you're going to be very careful when you're finding the center on hyperbolas, because y could be first or x could be first. So when you're finding your center, you just have to make sure that you look and see which one is first. Don't automatically assume that this is always going to be x, the x coordinate, and this is always going to be the y coordinate. Again, if this were first, then, or if y were first, then we would have to make sure that we know that this would be the x coordinate and that would be the y. Okay, if the hyperbola is horizontal, we want to know if it's horizontal or vertical. Since the x is first, it's going to be horizontal. The center is at x coordinate is 2, y coordinate is -3. A is under the first term, so it's going to be 4. B is under the second term, so it's 7. And notice in both of these examples, A was bigger than B, and that's okay. Remember, A can be greater than B, A can be less than B, or A can equal B. Okay, then we're going to find C squared by adding the two denominators together and taking this, and then to find C, we take the square root, so that's 8.1. Vertices are going to be on the x-axis because x is first. So we're going to add and subtract 4 from the x coordinate. So that will give us 6, -3, and then -2, -3. We're going to add and subtract 7 from the y coordinate of the center. So we have 2, 4. And 2, -10. And then we're going to, since the x is first, that's where the vertices are and also where the foci will be. So we're going to add and subtract 8.1 from the x coordinate of our center. So adding 8.1, we'll get 10.1. The y stays the same. Subtracting 8.1, we get -6.1, and the y stays the same. Okay, now, the next thing we need to do are, for both of them, are the slopes of the asymptotes. So if we're looking at, let me see if I can put this on with the problems and get them both on the screen. Okay, there we go. Okay, so we have a vertical hyperbola, which means we need to go to the vertical column here. And in order to find the slopes, we need to take plus a over b, or positive a over b, and negative a over b. So that's pretty easy to do. We just look at a and b, and we're going to do 5 over 6, a positive, and -5 over 6. And then for this one here, it's horizontal. So we go down the horizontal column, and it's b over a, positive or negative. So b here is 7, so we'll put 7 over 4, and then -7 over 4. And those will give us the slopes of our asymptotes, which we'll be using tomorrow.